Perfect. 3, 2, 1.
Okay.
Welcome back to another presentation for the data track here at this exposition. I'm happy to talk after a lot of technical, practical, and theoretical talks. Let's actually dive into the food industry and talk about big and small data, applications, and real-life use cases. For today, we have Antía Fernández, Intelligent Systems Director at Gradient, and I'm happy to open the stage to you. Enjoy.
Okay, thank you very much, Alexander, for this short presentation. Sure, here we will talk about real industrial applications of data analytics. So, well, as he told, I am telecommunications engineer, and also, well, I have both walls like MBA as well. I am, and currently I am working as the co-director of the Smart System and Intelligent Systems Department of Gradient. Gradient is an ICT center in Spain, and I'm leading 40 engineers with the ultimate goal of promoting the digital transformation of companies, most of them SMEs, through the Industry 4.0 with data capture and also processing the data for their business goals. So I have been more than 20 years applying ICT technologies in the ICT world, but the last 10 years I am applying this to the industry, different industries, like for example, the automotive and also the food industry. And here I would like to show with you this applying of artificial intelligence, big data, and we will see like usually we are not using nowadays, most of the business cases are not big data, but small data, because these data are not available in big volumes of data. Well, I am also an expert for the European Commission, and I'm also working in the research field and also evaluating and reviewing R&D projects for this Horizon Europe. But what I like the most is to have the hat of going through the different industries and applying those technologies. Okay, so I will start quickly showing with you this map that shows that Gradient is in Spain, this ICT technology center, and the aim is to promote the competitiveness of the companies, also transferring knowledge and technologies through different fields. We are more than 150 professionals, and we have more than 15 applied patents, and also we have worked in thousands of R&D projects. And also we are working for many countries all around the world. Our funding comes from, most of the funding from private companies and also another European projects. And what are we focused on? What do we do? We had the data on the middle of our technology strategy, and we do connectivity, intelligence, and also security. So after 10 years of activity, we have been positioned at one of the best ICT centers in Spain, and in cybersecurity and also connectivity, mostly with 5G technologies. But here we are now to talk about intelligence, which is the department I lead, and we will take care of capturing and also rather identifying relevant data for these food industry business problems. All right, and how we will explain all those use cases. So first of all, we will share how to start for a company, for an SME that would like to know how business data can be managed in order to improve their decisions. And then we will see different use cases for production facility, also for the business related with raw materials, purchasings, or also forecastings. And at the end, we will see some of the use cases for regarding people, also the employees and also the clients. And if we have time, we will see the future of the AI in this industry. All right, so how to start? Well, the industry have changed a little bit, and these changes are related with connected companies and also optimized companies, transparent companies, agile companies, and also proactive. So the idea is that we can use this real data of the company, not just for different departments, but also for the people that are working in the different departments in order to improve their decision making with this data. So each of the use cases will have in one people for these different departments in this industry. And okay, so how to start? You can see here, probably you cannot see anything, but this is the slide for the big data science and artificial intelligence in the 2020 year, and we can go crazy if you want to use this information, and we will not know how to start. So please forget about all those technologies and come with me in this process. So how to start is, yes, the beginning is what is the process that you need to be focused in your industry. So the beginning, all data analytics process in the industry are supported by, well, these three main steps. And the first of them is to gather all the information that are relevant for your problem. Secondly, you will have to convert the data into useful information. And the idea is to use analytics and also processing algorithms that allow you to extract the knowledge. So it's important to have this non-obvious relationship between different types of data in order to improve your decision making. And thirdly, we will support this decision making by collecting this data and share with the experienced people. So the first of all is be sure about your business strategy. And when you already know your business strategy and what problem you would like to solve, we will gather the data and we will apply different algorithms depending on what are these questions you would like to show. So, well, what are the truly important data for this food industry? I like to describe them in three axes. And, well, the first one is the data from the production plant, and it comes from sensors of the machines that are producing the food, and also from the product characteristics. We will see more in depth some examples. And the other side is the business information on the purchases, the sales, the suppliers, orders, and so on. Also, external resources are relevant for the business data strategy. And lastly, as we will see some of the use cases, the people-related data that are very useful for our decision making. So why artificial intelligence? Well, we should make sure about the problems of the industry. So next I'm going to present to you different analytic solutions for these three different environments. And well, in the production plant, what happens? So why we need to apply artificial intelligence in the production plant? For example, what does it happen? There are many stops in the process. And what are they made from? For example, the mass breaks. So if the mass breaks, we need to stop the process. What else? Change of the blades, the screens on the saw, different other breaks like the mess, the bed, also different temperature change for cooking or frying different machines that needs to be changing this temperature with the idea of having the food in the correct point. Also, some of the products need to be reprocessing, and the causes could be the product is overweight, the packaging bag gas distribution is not okay, or for example, the bags or the containers are broken or open, so need to be again put them into their bags. Another different situations are the product rotation of, for example, waste reduction based on poor cooking or frying, and also lack of stock could be another problem that face this industry, as well as another different industry. So, well, what are the challenges? So here we can see the first of them are check the cooking conditions, for example, the dot. So the idea is that we need to relate the kneading parameters with the stops. So we know the kneading parameters with the stops and also the breakage of the dot. With this idea, we will reduce the stops of the process. Also, it is important to control the hovering of the things. So relate this vacuum viscosity with the things, the rotation of the sealing, and also with this rinse of the frying to have this avoiding these problems in cooking. Another relation we need to face is the sealing of the bags in order to reduce these open bags in the packaging. So the packaging is important to be okay in order to stop the reprocessing of different foods. And the fourth challenge is to reduce the overweight. So the industry will lose many of the product if the product is overweight. So this product could be going to another different one. And also the last ones are related with the raw materials. So it's important to match also the production with the raw materials. And lastly, the forecasting of the logistics for the prediction of the production in order to don't lack stock and things like related with that. So which analysts are we using depending on these problems? So it depends on the problem, we will apply different analytics. So if we would like to know what is happening, we will use this information in order to explain what is happening. And we would like to know why it happens. We will provide as data scientists the knowledge about that. But if we would like to know when or what will happen, the prediction algorithms are the best for the solution. And lastly, some of the optimization algorithms will be useful if we can show what we can do in the problem we would like to solve. All right, so let's go with the production facility use cases. So if we gather data from the production, we have seen some of them, but some of the data that come from the production of food are related with temperature, the pressure, also spin and line of the belt. And we can also know different process or cooking situation, just for you to know, in the process of, for example, pre-cooked food, for example, like cooled, cleaning, bare, heavily, some filled in the same package, for example, the baking, the frying, also the frozen, and each of these process in the food processing had different sensor parameters that we would like to know in order to reduce, for example, the stops or other different problems. And also the other data we can gather from the facility are the product characteristics. So we will know, for example, in the fish procedure industry, the temperature of the block of the fish that are at the beginning of the process that the industry would like to be piece in different pieces. Also the viscosity, the conductivity, the humidity, and other parameters of the food. So today we will show these use cases, and the first of them are the product quality. with the sensors of the different machines. So I'd like you to be for a moment the professional that are working in this quality control. So you do usually, as the quality control manager, you do regular checks on the defects of your food or your processed food. So what the artificial intelligence have solved. So this system we had created had predict this generated product quality before knowing or seeing the product or also tasting them based on the sensor data. And I will keep on going different features and also advantage in order to share with you most of the use cases. But with the idea is, if we don't know the parameters that it is impacting in the quality, we will know at the beginning which of them should be the most useful parameters for the prediction of the quality of the food. So at the end of all, the process will be optimized in order to know these conditions. And in real time, the industry would be able to know if the characteristics of the food are in the best quality. Also, the condition monitoring could be applied for different vibrations of motors and also rotors of different machines there in the industry. And I will keep going because predictive maintenance is very useful tool in order to anticipate these failures and also unexpected stoppage in the oven of the food. All right, and now I'd like you to keep the different position, and I'd like you to be the production manager. So the number of planning systems that are in the market can optimize the different foods that should be put into the line in order to maximize the times that we are facing to our clients. So, for example, this is a real case of the finite capacity of the production scheduling. So what this system have allowed? So the machine in real times know if they are using or not. I will show with you on video as well. Also, the MES data is not using, sometimes they are not using a production schedule. It depends, the schedule depending on one person that shows the idea of going with this food or this another food. So the optimization is very useful in order to improve their productivity and also minimize the lead time and also balance the production between the different machines in order to maximize the product created. So this is we can see here at this source of a different source of production orders demanded by the information. We can upload this information to the system, and we can gather this. With this information, we will store, and we can see here, after improving the different parts of the production plan, this planner allows the optimal scheduling of the production orders to obtain the orders that all of them can be completed as soon as possible. So the results are a chart with the optimized production plan. And now we will see also if the machines are being using or maintenance or different situation. And the planning production plans will manage the KPIs indicators. So the planned use of the planned resources, and also on the other hand, you can see the fulfillment of the different deadlines of the production orders as well in the chart of the KPIs. Another different algorithms that we can apply also allows to see the occupation and also the forecast state of all our resources. So we can see here some of the resources that are occupied or they are in. So this is the distribution in percentage of the values of the states. All right, so another different use cases for the production facilities are the control of the raw materials and performance during this process, and also the stock availability for the planning. And it's important to optimize and simulation the process in order to have all the information for these high availability environments. And also the stock optimization is another use case that we can use data in order to know if they are using. Okay, so here you can see, I will show with you a video. No, I cannot show. Yeah, I can show with you here. And you can see here the different stages of some of these squares are some machines, and the product is going from the beginning to the end of the process. And we will know here how many time it lasts to produce a different situation. So with this information, it is useful in order to simulate and also to improve and optimize the times in each of the parts of these machines. Okay, I will. Let me close this video. Yeah, I'm sorry. Okay, and the last use case for the production plant facility are related with the energy consumption. So in terms of the energy efficiency, the most relevant use case also had for our client 200% return in their hydrogen flow and also costs. So it is considered of automatically identifying the regulation of the hydrogen flow for the best and optimal conditions of the generated product. Also, it is important for you to know that this monitoring and also regulation is automatic. So nobody needs to be there in order to regulate the flow of the machine. So the process is automated, and the ideal caudal are also created automatically. And also the consumption regarding data from meters, and also to knowing the threshold in which you need to turn on and turn off different machines in order to have the best condition. For example, a frying machine with the oil with a correct temperature, sometimes it's not necessary to shoot off this frying, because it is most time consuming and energy consuming if we turn on later on for frying another different food, for example. All right, but well, the future of the smart factory is not about just the facility, but also we need to mix all the information and not have the information in silos. Well, this is why I also say that the business and also the people data should be together in order to take some different decisions. So let's go with different business data analytics situations and products we have applied to our clients. Here you can see some of them, and I will go deeper in some of them later on. So some of them are the optimization of raw material purchases. Some of the purchases are the higher costs of the product that they will generate. Another part is the traceability and also the product life cycle, also with blockchain technologies. and what else? The route planning for the distribution in order to optimize this transportation, and the end customer behavior prediction as well in order to help us to the sale forecast or also demand prediction. All right, so which information should we use? Which are the input data for the raw material purchases? So most of the information we use are internal knowledge of the company, because, well, we have used as well historical prices of the hake, the mussel, the different fish species, cod, and other different fish species. But the most useful information are the experience of the people that are working in the fish purchases. And this information is complex to gather and also is complex to predict. So what was the process we have followed? So first of all, we have analyzed the available historical data of the prices and also the indicators that determine their suitability in order to forecasting models, and differentiating with the idea of differentiating different raw materials and not to mix different fish species. Then we designed the forecast models for different pieces of raw material. But the information that is useful is the models that have more than a year or more of the forecast, and also with not many error from the prediction forecast. And then we implemented a model based on web services and so on. But well, I will share with you the real problems, that the real situation of the companies is that this data is incomplete. So the time series have also data missing or started later, or had maybe less than 100 observation of the prices of the raw materials and fish. In other cases, the information is minimal, and also the price variations are minimal. So the forecast, well, is not very accurate in order to create this accurate forecast. And also there are relevant catch volumes to compare with the final plans, and the catch volumes are not that relevant. So we have learned that the best data are the data from the capture information from the different and also the price, and also the capture of these fish with seasonality catches, and also prices depending on the seasonality. And also if we had the information about past values of the price. So at the end, we designed linear regression algorithms in which we estimate the optimal coefficients for each of these predictions. But we have at the end this situation with these algorithms based on the data we had is not really optimal, and it's not very good predictor of the fish prices, but it works better with another different parts of the food industry and different other foods. For example, with oils for the frying machines, it works better than from the purchases of the different fish species, for example. Well, this is another business use case for the food industry. So we have talked about production facility, and now we are seeing different business use cases. Well, so this is the product life cycle in the market. So just for you to make clear that the product life cycle in the market have 5 different stages. The first of the stage is the introduction, where the market, where this product or this food go to the market for the first time. The second one is the increase of the sales. The third one is the maturation. So after a time in the market, it consolidates their fluctuations. The fourth stage is the decay. So it loses a little bit of the market interest, and also decisions are falling. And the last stage is the decline. So there is a residual volumes, and also it provides losses for the company. So what is the objective for this business case? The objective is to predict this curve for a new product. And when you provide this new product market curve, so you will know in advance what are their market situations. So it will help you to discover which strategies you should follow for going into the market with this different product or food. And the data sources for this life cycle curve are usual historical data of the sale volumes from different reference, but slightly different reference, and also the product data, the shape, the flavor, the texture, and also the nutritional information. We used, in this case, different hardware services these systems are implemented with different APIs with the idea of facilitating this integration. And we have also used Docker technology and fast API in order to share these services with the company ICT department. And these different algorithms we have used here are clustering. So these algorithms generate characteristics that are use different variables of origin, normalization, and most important variables in order to characterize the product, and also the classifier. So what the classifier does is to obtain the curve with the attitude that are predetermined by the different variables. And we have proven different of these algorithms you can see here in the image. Okay, now we are sharing with you another different use case for the business people. And now you will see this use case as the shopping responsible for the company. So the idea here is to know in advance and produce the customer demand and also to compare it with the real-time production facility capacity of the plant in order to have both of these parameters, one with the other in line. And this is another use case. All right, and now we will go with the people use cases. Here we are. Okay. So regarding the people data analytics for the food industry, that we have already seen the plant-based data and different scenarios in which we have applied data analytics for the plant. We have seen different business use cases for using data and helping business people in the food industry. And finally, I will show with you different use cases of applying data analytics, and all of these situations are based not in big data, but small data, because all the data we have from sensor, we have from historical prices, the data from sales forecasts are not very, they don't have a high volume, and it is the same with people data. So we will help with these solutions to the human resources department of this industry. So changing the culture is very valuable, and also the transformation doesn't go with changing the culture. So the HR manager needs to manage a lot of skills profiles. And these skills profiles are different for each job and the worker that that need to go from one part of the facility to another need to have different skills for different jobs. So the analysis of the CV and also the skills of each employee help the human resource department in order to change the different jobs within the facility. Another analytics of this employee information is the absenteeism prediction. So we are helping to support, to predict. We are not, we can predict the absenteeism, but we will not lower the absenteeism. But the human resources department can make a more hiring or temporal hiring in order to cover the absenteeism of people, because he will know in advance if the people are coming or not, and so that they will be able to face with all the production planning for the day. And I will go more in depth for the last one, which is related to customer experience and also customer's journey. And I will share with you later on. Well, here I can share with you. I think this is a video. Okay. And you can see here the different departments. So this is absenteeism from people of a facility. And some of them have been in the hospital or going to the medical appointment. And you can see here the different profiles of this absenteeism, depending on the department and also depending on the age. So the human resources responsible can have the information about the skills of the people and how many hours are working, and if they need to be some new hiring or whatever, depending on the production, depending on the time. And these absenteeism are usually stational as well. Okay. And also here you can see the talent management dashboard, in which we know the different skills of each profile. We can detect the internal needs for training and going to different parts of the jobs in the facility, and also the evaluation of their level in each of the parts of the facility. And well, for the customer experience and also the customer journey, we have applied the NLP, natural language processing, of most of the social media. So the company will know if the customers are talking okay or bad, or they like the products, regarding of the information that are writing on Twitter and also on Facebook and different social media. So the idea is to gather all the information and to make different marketing campaigns or other decisions regarding their image, public image of the brand of the company. Okay, so if we already know the different situation in our food facility, okay, so how we can start? Well, how we have done it is with a tool, with the idea of this tool, which is called Clever, is shortening the time to market of each algorithm for each of the use cases that I have already presented to you. But I have learned in all these years working with different companies from different industries that each of the problems are different, and the problems are similar, but the data are very different, the machines are different, the sensors are different. So each time we need to create a new algorithms these algorithms are new. So let's say that my team value is to be like data artisans. Together we will gather with different tools. You can see here many tools and technologies for artificial intelligence that we applied, and each client have different technologies and also different standards and other technologies and also different data. So each time we create a new solution, we use this solution for the customers as it was the first time. And also we know a lot of different algorithms we have already applied for many sessions and many other projects. So this is the knowledge we can provide for each of the situations, and also how we can do this strategic service. So we do a diagnostic at the beginning, then we create an innovation strategy advice, and then we provide a different recommendation. At the end, we start with the proof of content, but later on, we keep the solution working in more TRL level. Okay, I close here sharing with you different large and SME companies we have worked for, and I think we have left about 3 minutes left. So I will finish, and I don't see any question. Okay, so I will finish this presentation sharing with you my vision of the future of the AI in this food industry. And well, the data right now are not very reliable. Well, let's say the data is reliable, but the algorithms are not, because for example, the production plant manager, also the HR department manager or the maintenance manager don't really believe what is happening inside of the algorithms. So the algorithms are not very reliable right now. So the explainable AI is necessary in order to make them believe in the algorithms, in order to make this most of the decision automatic, because otherwise the decisions will be a recommendation, and what we are doing is the recommendation for decision making, but any of these use cases I have shared with you are, well, the energy efficiency, yes, but the others are not automatic in order to actuate in the machines. So there are humans that say, okay, I'm okay with this recommendation, let's go. And with the explainable AI, there will be a very useful solution. And I will keep going. And other technologies are augmented analytics in order to solve the problem of not reliable data or not many data, and also visual analytics, adversarial learning, and privacy preserving machine learning. And lastly, the idea is to make more efficient AI in order to include the algorithms in different machines and very low cost energy machines for these algorithms and the processing of these algorithms inside of the facility, with the idea of not going out to the cloud and coming back. And some of the technologies that will come are data augmentation, data efficiency, data quality, and transfer learning. Okay, so that's all from my side. Thank you very much for your attention, and please let me know if you have any questions or whatever. You can chat with me.
We do have, actually. Thank you for the quick talk, Antía. We have a quick question coming on from Anders before we close up. Hi, and thank you for your presentation. Is there a big difference in the maturity to be open for this in the new industry? How is the reaction when you talk about ML AI into industry?
Yeah, let me It's a big difference in the. Yeah, sure. There is a very, very important difference. For example, I can see between automotive industry and also the automotive industry is, how to say, it's more near to the 4.0, and also the food industry is more manual. So at the beginning, we don't have neither data, neither we have integrated machines and also communication. So the reaction at the beginning is okay, I will not believe in this system. I will not use this recommendation. So it is a process in which we will learn from the industry, and the industry will learn from the data scientists. And it is a very slow process, and also very, very complicated, sure. So the reaction is, okay, I need to learn in order to believe in machine learning and artificial intelligence. It depends, most of them, of the culture and the innovation culture of the company.
Yeah, budget and industry are a bit different as well. But hey, we're already running late. Antía, thank you very much for your talk. Interesting enough to pull it through the last second, and useful just as much. For now, I would like to end the session, and for everyone else, thank you again for your time and attention. If you have any questions, you have our contact details here on the platform, or use the chat later.
Thank you. Yeah.
All right, good one.